Okay. Yeah. So now, actually speaking, we were talking about this topic. That is when we took a digression to other topics like the time and all those things. Okay. So when before that time we were actually on this topic. What was the shape of the earth? What was the original idea? And it's telling that people had this idea that earth is spherical much before. So it is a misconception in people that during dark age people were thinking earth is flat, which is not right. So this is a knowledge which is there for probably from 12th century BC or 13th century BC, like that. So, which is a much older knowledge, more than 3000 years the people. So how they knew? We were telling one of the thing is they looked at like eclipse. So once they go to know how eclipse is happening, then it is like a mirror. Actually, this moon acts as the sun's mirror. So you by looking at the edges, and this position is like, the center part is actually earth. So you can see earth exactly as a round perfect stuff. So that is one of the point for them to believe that earth is not flat. Because earth is flat is a normal thing for you to feel, right? When you look at it, it looks flat. And then another point was this, I was mentioning this star called North Star, or Polaris. It is called Polaris also. So this is on the, as of now, in the current position, it is above North Star. Due to that precision which we talked in the last class, it will change a bit. So in the precision, when this axis shifts, this will slightly change, but as of now, mostly it is above the North Pole, which means when you travel away from North Pole, you would feel this Polaris height is increasing. So, and when people travel from other regions towards North Pole, you will feel like Polaris is coming closer to you, straight above your head kind of stuff. So that was one of the stuff. So people used to use this for, travelers used to use this for their, if they lose the way, lose the path, they used to look at Polaris to know how much they have lost kind of stuff. Okay. So this was another point. So this can be possible only if earth is spherical. If it was flat, the height from earth to Polaris should have been uniform wherever you go. So this is another point. So which means it's a very rational thinking. They are not like bluffing and things. It's a very rational kind of thinking behind this. Now then the third proof, there are many other things. The third thing was like the sea in the horizon. So normally when people look at sea from the horizon and the beach, especially in places where you are like, where you have a large wide horizon, you will see first the tip of the vessel coming, the anchor, the tip. Then slowly after some time you will see the backside coming, right? And they realize that is possible only if the shape is spherical. If it was flat, you will see the entire vessel at one go. So you will see only the tip first like this, only when the shape is spherical. Okay, and then due to trade, many people used to travel and all at that time. So they got into a reasonable conclusion that earth is spherical. Okay, this is a very old knowledge, one of the oldest, but very important knowledge, very important knowledge. And then we spoke about few civilizations, and all those civilizations, if you see, people were inventing things for their day-to-day use. They have a problem in measuring earth, so they were developing geometrical stuff, and they want to develop wheels, so then they got into the mathematics behind the circle. So like they have to construct houses, so they came into bricks and all those things. So it was all based on utility. Like you have a need, like you are living as a society, you have a need, so you have to develop something. That's where we call necessity is the mother of all inventions. It's a very famous usage. Necessity is the mother of all inventions. So you need it, so you will go and find it, kind of stuff. But then slowly after this four civilization which we spoke, which are mostly from that 3000 3500 BC till around 1500 BC, then after that came this new civilization, which actually was path breaking. People started, that is what we call as Greek civilization, which could probably, arguably, be one of the first modern civilizations, what we call it as. And it is so modern that it ended during after the Alexander's time, after maybe this first, second century AD, around 1800 years back, when it ended. So there is a school of thought that if they would have continued probably for 2 or 3 centuries more, they would have reached scientific revolution at that time, maybe Renaissance at that time. So they were so advanced. So whatever we learn today as the basics of science, philosophy, and many other things actually paved way by them during that time. And that is the time people like Socrates started coming and thinking about how this universe is working, which is very different from you finding out something because you have a utility. You have a need, so you develop something. That is different from people start thinking about how this universe will be functioning. So that is a one pedestal, one level above. So that is how people like this philosophy, the people started thinking about philosophy, why you have come to the earth, what is the purpose of your life, and why earth is there, and why sun is there, why we are here, that kind of stuff. It is not that people did not think before them. There were people thought kind of things, and there are many inscriptions and all, but these were very profound thinkers. So Socrates is known to be the person who propagated the theory of questioning. His thing was question things. So you keep on questioning things, and then you can develop knowledge. But then we don't have any reminiscence of whatever Socrates was thinking about. He has not written any books. So what we know about Socrates is best by his disciple, Plato. So he had written books. One of his famous book called Republic is actually Socrates comes as a character there. So it was like they used to write books like drama at that time. Maybe because they fear the regimes, because they fear to tell something openly. So they bring a character, like you also do. So you don't want to tell something, so you bring a character to talk something, tell something which you wanted to tell. So the Republic, it seems to have multiple characters. One of the characters is Socrates. So this is a conversation between these different people. So one of the characters will be telling what Plato wanted to tell. That's a style which people used to adopt during that time. So they will bring different views. So one person will tell one view. No, what if Earth is flat? Another person will tell that no, Earth is not flat because you can see the vessel in the horizon, only the tip first. So what happened? The argument and counter argument, both are coming in the same book. So you're killing the argument there itself. What all could be the prospective argument? It's not just a one-sided view. They bring the other side view also, and they leave it open. They don't tell that this is the conclusion. Okay, so a style which has existed in many other parts also at that time. So Plato, unlike Socrates believed that you can keep on questioning things and find out how the universe is functioning. Plato was having a different school of thought. So Plato believed that whatever we see in the universe, in the earth around us, are actually not the real earth. So he believed there is something called ideal universe, ideal world. So he took many examples. Like one of his famous symbolism there was that he was telling a chair, what you see. The chair, what you see, is made by a carpenter. And he has an ideal chair in his mind. And this person is making a chair, but that whatever he has made will never be as good as the so-called ideal chair. So instead you make anything, whatever you see around you, you see people. But that people are not the ideal people. A person called ideal characteristic would be there. But whomever you see, everyone you call as human being, people. So the people name whatever you have in your mind is the ideal human, ideal people. But these are also people. So his thought was that there is something called an ideal universe, which is basically defined by perfect mathematics. So he had a lot of things like music. He was telling there is a synchronism in music. He was telling in flowers, petals, and everything. There is a mathematical synchronism there. So his point was that this so-called ideal universe works on perfect geometry, perfect mathematics, but then what we see is only a shadow of that, or a replica of that. So we should be finding what is that ideal universe. So that should be our journey, our search. That was his concept. So as you know, like we also in Indian philosophy also, we had very similar concept, right? And we have whatever we call as like Maya and all, you know, this is very similar to this. So we tell whatever we see is Maya, but actually there is another world. So we, not another world, by telling that, you know, there is another ideal stuff. So this Atman, Brahman, the the whatever we call as Advaita, and so non-dualism and all have pretty reminiscence, but they call this as dualism, Dvaita. Dvaita means he tells ideal universe is different, what we live is different. But our Advaita says no, both are the same only. But whatever we see as human beings here, we have from our soul. All the souls are connected internally, and then that forms the Brahma. So that is the Advaita kind of concept. So it is, one is dualism, one is non-dualism, but very much related, right? So all these people, the what is that famous book here on based on Advaita? Our friends, oops. So all these Hollywood stars and all swear by that book, no? Somehow I didn't like it. Oops. I'll just tell when I remember. Alchemist, right? Alchemist, yeah, means very big hit. So it shares the similar concept by telling that you can, after some point, you can control the nature because your element and nature's element, that's interconnected. So very close to Hindu philosophy, Hindu philosophy. So the point is, like, it is not like there is one philosophy or one kind of ideology which is very sacred or which is very much separated from the whole world. So it's all intermittent. Whatever we say here, some part they were telling, some part they would have been told in China. So it's all interconnected. So the knowledge is, we don't know how it has got propagated, maybe because of people who travel, or maybe because in similar circumstances all grow up. So it's a very big topic of discussion. Like you grow up in similar circumstance, but in two different parts of the world, will your thoughts be same?
Maybe the inner design is same, like we all are human beings. So
yeah, maybe we don't know whether you will think the same. Like Arun is here. Let us assume there's somebody else in some other part. He was brought up. Tomorrow we find out by telling an alien a planet is there. Maybe they may draw pictures like projector. You don't know, right? You know. so it's like, it's a very complicated topic. First of all, that itself is a very, why there is life on Earth is itself is a very complicated topic. There are so many theories with regard to that. In that itself, within Earth, two people staying in two different parts who have not met before, there are many people who think alike also. Okay, and there are many people who don't think alike also. So if you look at it, I think the one of the tribe whom we can still call as hunter-gatherer are the people in Andaman Nicobar. So that specific parts of Andaman Nicobar are the people who are still the real so-called hunter-gatherer. But then you see, we can't go there. That even 2 years back, a white guy who tried to go there, they killed him. So they don't think that, you know, you and them go together. So it's a very complicated topic. It is not necessary that every time they also grew up in the same world, they are also in the same earth, they have same brain. It's all similar. Okay, so which means this your brain development, that is what I was telling in the first class, that the civilizational progress in the development of brain is a very big thing. So in that, art and culture and all will has a very prominent place, is what I think. That's what I was telling in the first class. So then the brain develops. So brain can be trained. That's what they say. Brain can be trained. A bit complicated. Okay. Yeah. So this is where, you know, this word called platonic love and all comes. You might have heard platonic love, right? Have you? Yeah, I don't know heard, right? So platonic love, platonic relationship means relationship without having the physical intimacy alone. So platonic means you have like a very good relationship with someone. So people tell no, that person now is relationship. So some people tell no, ours is a platonic relationship. Means it is not based on physical things, but not based on sex. No, it is based on pure relationship. So that Plato, it's ideal. That word itself comes from there. Platonic stuff. Yeah. So then, so this is one of this thing to explain his thing. What he told was this concept. This was his explanation, right? As an allegory of cave. So he was telling what you see in the earth. He's telling all the inhabitants of earth. You see these things here, and you think this is the real world, real earth, but which is actually our shadows of something happens in some other plane, for which the light is provided by somebody else. He's telling that light is provided by someone else, and the reflection of that light is the shadow actually. But the people who see in the earth believe that this is actually what is really happening. So she's telling us allegory of, it's a very famous stuff called allegory of cave, Plato's theory. Plato has coined many such terms like this. He's telling then by mistake, if one person comes out for this, when he comes out, he can't see anything. Because he was sitting inside this dark cave for so long. So if he comes out, he can't see anything. You will be blinded actually. You can't see. You can't look at the sunlight, you know, will be painful for you. Then it takes some time for you to slowly, maybe few days, few months, to really start looking at things and see. And then probably you will start seeing the real things. Whatever you thought here are the things, he will see the real horse, real things. And he tells when this guy goes back and tells that, boss, whatever you are seeing are wrong things, they will never believe. And when he goes back, he will also tell he can't see anything because he's been so used to sunlight, he can't see anything when he comes inside. And these people, it seems, will tell him that you have become blind because you disobeyed and went out. So that is the profound analogy or allegory which Plato gave to describe this situation. Does that make sense? Does that make sense? Okay. Yeah. One you are there, I hope. And
Yes.
Yeah. Imartha sir also. Okay. So catch me like, it's like I'm just throwing these things. You will know better philosophy than me. So I'm but just throwing these things so that probably you can go and search these things. And Plato has put to coin 2-3 other terms also very similar to this. But do you look at the analogy he has brought in? That is beautiful, right? Whether you agree with that, disagree, just to tell a concept, he just put something which is very worldly. And that explains everything. Well, the picture is not drawn by him, picture is drawn by people later, but you know, that is very profound, right? I may not agree, I also don't agree, but what you agree or don't agree is a different thing. It's a different part. So that is Plato's concept. Okay, so then after Plato came Plato's disciple, okay, who people believe is, if you take the most intelligent 10 people ever born on earth, he could be one. So he's supposed to be what you call as polymath. So people call it as polymath, Polymath. Polymath means person who has multiple intelligence. So this multiple intelligence theory is a very widely accepted theory, that you have musical intelligence, you have kinesthetic intelligence, you have mathematical intelligence. So like that, you have visual intelligence. So there are 8, 9, 10 intelligence. So different people who excel in different things are based on which all intelligence you have more. Everybody will have some of every part, but some people will be very good in some of the intelligence. And so some people who are there, who are very intelligent in many of these things are called polymaths, like Leonardo da Vinci kind of people. So will draw, he's a scientist, will do multiple things kind of stuff. So Aristotle is supposed to be a polymath. Okay, one of the first. There are many, one of the first. Okay, so Aristotle then he further revolutionized the thing which Plato told. So Socrates was telling you can question the things and find out what is happening. Plato told boss just questioning is not sufficient. You have to identify what is that ideal universe. You have to figure out the mathematics behind this. You have to figure out the geometry behind this. Okay, so then Aristotle told just by sitting and trying to figure out something unknown is not sufficient. You have to look at Earth, what is happening in the Earth, and observe what is going on, and then figure out how universes function. You see, it's a huge change from Socrates to Aristotle, which happened in 100, 150 years. It's a huge change. Aristotle, you go around Earth and observe what is going on. And then he went and observed. He went and observed the flora, the fauna, the birds, the animals. He dissected. He did, you can't believe, botany basics, zoology basics, what all we see, philosophy basics, what all we know basics, almost everything belongs to Aristotle. Unfortunately, what all he told now, we don't agree as of today. All those things are overtaken, but that is like that. It is like somebody will come and tell 2G, and then after that it will come 3G. So the 2G phone you cannot use, then it will become 4G, and then it will become 5G. That doesn't mean that the people who were putting 3G were fools, or the engineers who work behind 3G were not fools. So you are standing on the shoulder of 3G to make 4G, and you are standing on shoulder of 4G to make 5G. So you will make something, and that will be proved wrong. Then on the top of it, new thing will come. So that doesn't mean that the old people were full. So Aristotle but laid the foundation that you can observe things and develop things. So almost the entire science streams and all those things he made. And he is one of the first person who brought a theory for motion. Okay, which is notorious today, because based on the theory is what the so-called dark ages actually took around 1500 years for world to come out from that. So his theory was that, which is what even after the entire education, like when in my classes, when I ask the students, all of them will tell, yeah, this is right. Yeah, after the entire class education, school education, when I asked, 9 out of 10 students tell this is right. So his theory was that everything is at rest. Everything is at rest. So you are at rest at your house is at rest, everything is at rest. And if it is to move, you have to apply a force. So that was his theory. Rest is the basic state. So if something has to move, you have to apply a force. If you apply force, then it moves. So do you agree? Arun agrees. Vani agrees. Prajakta agrees. So now, unfortunately, this is the sad part of the school education, right? Because unfortunately, like this is how we are being taught science. Okay, so the whole should I wait, Prajakta? I think Prajakta went to go and see whether something is moving inside her house or whether everything is at rest. Prajakta went to see whether everything is at rest or really moving at house. Okay. Okay. So should I wait? Do you want 2 minutes? Okay. 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 So see, the point is, actually speaking, this is blatantly wrong. And this is what caused for people to think that Earth is the center of the universe. And this is what made people to think sun is rotating earth. Okay, and it took up to Newton, and before him another gentleman called Copernicus, and before him some Arab scientist. So you see, this is 384 to 322 BC, 4th century BC, and this was corrected in 14th century AD, which means close to 2000 years, 2 millenniums it took for people to correct this. And all that time people believed that earth is the center of the universe and sun is rotating earth, because they felt everything is at rest. Earth is at rest. You see around, earth is not moving, and you need a force to move earth. Who can move earth? Earth is a divine place. All gods are here, all prophets are here. So this is a divine place. So that time they had not known about galaxies and everything. So who can move earth? So the theory that what we call a geocentric universe, that earth is the center, came from this concept of Aristotle. So simply 9 out of 10 kids, or maybe I will tell 95 or 98 out of 100 kids will tell the same thing which you tell, because they have been taught wrong. Okay, and they will learn all Newton's motion and everything, which you will learn in the later part, which is actually contradicting this. But then they have not understood it. So you ask the students, can you tell Newton's law of motion? They will tell like a parrot. They will tell like a parrot. It is like you tell them what is after P, they will tell them 1 second, A, B, C, D, E, F, G, P, Q. So you will tell what is after W, they will again start A, B, C, D, E, F, G, this thing. So without going to A, B, C, D, you can't tell what is after W, right? So that is parroting. So that is the unfortunate part. So you ask them to tell Newton's laws, they will parrot. But you ask the same question, do you need anything, any force to move anything? They will tell, yeah, you need something, because that's what you will feel. If something is stationary, you need to push it to move. Okay, but we will see in the later part why this is wrong and how this is wrong. Okay, and this is a very important part. Okay. So then he told earth is the center, because earth is stationary, nothing is moving. You see sun coming from here, rotating earth. Evening he goes there. Night he rotates the other part. Back through backside it comes. So sun is coming and rotating, which look very, very plausible, which look very natural. And that is not the only reason. There are many reasons. They felt like if you just run. So when you just run, you will feel that wind blowing. Na? So if you just go in a car at 100 km/h, you will, if you just unwind the kidki, the window, you will feel the flow. So if earth is moving, you need to have that flow. If car is moving, if you just run itself, you see the wind. If earth is moving, you should have that wind. So you don't see any wind, right? So it looked very stable. So they had their own scientific reasons. There are more reasons. For example, like you just point your finger to some object in your wall, small object, wall or room. Just point and close one of your eye. Okay, just point your finger to any object. Just point it to any object in your room and close one eye. Okay, point it, a small object, okay, not a huge object. Don't tell that I pointed to the entire wall or entire earth kind of. Don't be artistic. Just point to a very specific object and then open that eye and close the other eye. Open that eye and close the other eye. What do you observe? So, Prajakta, you're seeing it is shifting, right? Right, Arun, Vani, did you observe? Yeah, you observe the point is shifting, right? Yeah. So that is
yes,
called,
it's shifted. Yeah.
Yeah. So that is called parallax. That is called parallax. So what will happen? That is how our eye works. So our eye works like that. For example, like if you have, let us assume you are looking at an object, you are looking at a star. Okay, And in the earth, if you assume that you are in a point like this, earth is rotating, assume earth is rotating, earth is here, and from here you look at a star. Okay, so actually you won't see the star at that point. You will see the star is somewhere in this point. You will see the star here, like this. And assume that after that sometime earth is on the other side, opposite side. And from here, like earth is rotating, assume earth is rotating. And from here, if you look at the star, you will feel the star is here. Like what you observed just now. With one eye, if you observe what will happen, that's what will happen. So actually what will happen, if you look at you, if the assume these two are your eyes, okay, this is not theta, this is equal distance. Assume these two are your eyes, your one eye will think that star is here, other eye will think it will be here, and your brain processes it, it will take the intersection and tell that is the position where star is. That is how your eye processes. So that's why Rathnam sometimes, you know, when you close one eye and try to walk so that you don't disturb your sleep, you will fall somewhere because whatever you see, it's in different position, slightly. Just try to close one eye and try to walk or do something and pick something, or try to just take the cap of a pen with one eye and try to put it. You will know it is difficult because the eye it works with two eyes only. And the brain it will process. Okay, so now if the earth was like this, if earth rotates, actually we should see that during some time star should be here, during some other time star should be here, some other time star should be here. Star's position should keep on shifting. This is called parallax. It should move, actually speaking. Actually it moves in the earth. When it moves, the position of not stars, very small objects and all, you will see like when earth is rotating around the sun in different points, you will see it at different parts in the space because of this phenomena. But then most of the stars at that time, they felt their position is not changing. Their position is not changing. It's the same place. So that is one of the reasons for them to believe that earth cannot rotate. If earth is rotating, we should have observed the position of stars as different. The point is, they were not just fools to think that earth is the center of the universe. It's very scientific reasons. Okay, so they could not observe this phenomenon called parallax, and then they believed that this is one of the reasons why earth is just stationary. Okay, by any chance, can you guess or think why we are not observing this shifting of stars? Why is it, why we were not able to observe with naked eye?
Because of the space and the like it is so big to shift is not so visible.
So 2 points. 1 point what Vani told, these are huge stuff. Now you change the experiment by looking at the wall or outside. You go to balcony and point at a huge thing like a huge sky. You look at the sky and do this, you won't be able to see the difference because it is so huge. You are able to see this because you are pointing to a small object. If you point to the whole wall, you won't observe the difference. So the stars are so huge, and people, they were not knowing that stars are so huge. They thought that stars are not that big. So why they felt stars are so, because the stars are very far away from you, very, very, very far away from you, and they are so huge also. So because of these two things, they were not able to observe parallax. Okay, so that was another reason why they felt earth is the center. Okay, there are a bit more, we will talk about that later. There are more things. Okay, so then he also before him, the concept was that one of the concepts which Aristotle has told, which still stands today, is that the whole earth is made of two things, only two things. whatever see on earth are made of only two things. Just two things. You, me, the earth, everything is made of only two things. Do you have any clue? Which is, the current science also agrees to that. Whatever we see, the earth is formed, universe is formed, everything because of just two things.
Matter and antimatter?
Yeah, matter is one, I agree, not antimatter. Matter alone, you see, if matter was only there, there won't be any movement, right? There won't be wave, there won't be earthquake, there won't be rotation. Matter all will stay there like this. If it was only matter alone, it would have been idle, right? Yeah.
Gravity caused.
Yeah, great. Yeah, correct. Yeah, that is right. So forces. So matter and forces. Some forces are there, some matter is there. This is right from Aristotle's time. He had also stated. But even before him, people were telling that there are four kinds of matter in Greek. They will tell that earth, water, air, and fire. You know, it is very similar to what we tell in India, right? We tell Panchabhuta. We also tell earth is, whatever universe, earth and everything is constituted of five things called Panchabhuta. And to this we add sky also, right? Vayu, Bhumi, Jala, like the same thing, the same concept.
Sky is included in Panchabhuta, I think.
Yeah, it is included. For these people, it was not included.
Okay.
As you can see from the slide, for them, they told only till fire.
Okay.
Okay. Okay. So for us, they may be considered air and sky as same for them. Maybe, don't know. Okay. But then Aristotle added a theory of motion to it. So Aristotle told there are only two kinds of motions. He told only two kinds of motion are there. One is up, one is down. So one is up, one is down. So he told of this Panchabhuta, earth and water have a down motion. That is why when you put a stone, it is falling down. That is why when you put water, water is falling down. So because they are attracted. Down motion. And he told there are other two things, air and fire have up motion. That's why fire smoke goes up and the air goes up. That was his theory. Okay. So then this question came, what happens to these other things, other planets and everything? They actually rotate, right? So Aristotle introduced a fifth element. He introduced a fifth element called ether. He told, well, there is something called ether apart from this earth, water, air, and the outer space, whatever the space where itself was not there, whatever we see after here, those things are rotating, those planets are moving in ether. So this ether is another dangerous stuff which Aristotle coined. Actually, science took 2200 years after him to get rid of ether. It's only in the 20th century Einstein brought a clarity to this issue. World was running behind ether, so many theories, so many counter theories to know what it is, how this ether works. It is very complicated theories on ether. Many complicated because if it is ether, if all these planets are moving, you know, there will be friction. So when earth and things are moving, if you have, like, even just in a car goes at 100 km/h, you'll feel that sound of air. You will see when a flight goes, you hear that sound, right? Because it is going through air and that area will become hot. So here, like, if all these things are moving, planets and all are moving, then if ether, what is the character of ether? Then it should go and hit ether, and ether should become hot. And then what will happen to that? This is very complicated stuff. So this fellow left lot of ghosts for the world to play around after his life. And next 2000 years, people were playing one by one by one by one by one. But this matter and force still stands good. We also believe that whole universe is made of only two things, matter and force. Which all matter, which all force, we'll see at the later part. Right?
That's what I was going to ask. Like, if there is no matter, there won't be gravity, right? Because,
yeah, see, the gravity is a very dubious stuff to us till now. So till now, we believe, science believes that there are four kinds of forces. The whole universe is made of four kinds of forces. But then where from the force comes? Force comes from matter. Where from the force? The force cannot come from anywhere. Force is also coming from matter. So which matter causes which force? We have mapping, except for gravity. So we don't know how gravity comes. So that is actually the second theory of relativity of Einstein. Einstein tells there is no force called gravity. It's a bit complicated. But till now, we don't know how gravity comes. So people think there is a,
is there any connection with magnet, like those kind of, magnets are, there is an opposite energy, and these elements have any connection with the magnet kind of energy?
Yeah. So that is another force called electromagnetic force, which is agreed, approved. We know which particle causes it, which particle is causing electromagnetic force, something called gluon. We know that. That is identified. But which causes gravity, we don't know.
Yeah.
So people propose there could be something called graviton. Never found till now in any experiments. And Einstein tells it is not there. Okay. Okay. So for you, it is important to understand this historical root, where from it comes. Okay. So then what happens is another thing on a lighter note, which is surviving till today, is Aristotle's theory of friendship. Okay, that is still surviving. So Aristotle told there are three kinds of friendship. And out of that, only one will stand. There's only one kind of friendship, Aristotle was telling, that there is something called friendship of utility. Utility means kuch lena dena hai. Okay, so like you are staying in an apartment, and then you have two people in the apartment, somebody who comes and gives you milk, and somebody who comes and does some servicing, somebody, the owner of the apartment, or maybe you buy something from the next shop, or you go to the nearby sari shop nearby. So you have some business with some people, or somebody gives you painting material at a good price. So you have a utility relationship. So over a period, you may make some friendship with them. Naturally, you may make some relationship with them. Okay, it's called accidental friendship, it is. If instead of that person, if somebody else was giving you paint, probably you would have made relationship with that person. Something like that. Or probably you are staying in same apartment, your neighbor was somebody else in some other apartment, you would have made friendship with them. Kind. And then the second kind of friendship, you told that based on pleasure. Like you have a hobby of stitching, then every day you go and you go to loafer club every day morning, you loaf it out, then you start meeting that person. His daughter also studies in 8th, your daughter also studies in 8th, and you have similar pressure, and you have so much of bad words to give to the school and the teacher, so you find a commonality in that. So that is based on pleasure kind of stuff, or you play for the same club, things like that, some activity, something kind of stuff. Okay, so which is also some kind of friendship, but he says this kind of friendship will not stay the test of time, or test of pressure, or test of adverse events. It is only what will stay is the friendship made out because of the virtue, because you appreciate the character of someone else, you feel there is some values which are common to you and that person. And then probably you make a friendship based on out of that, not because you have a dealing with them and not because you go to the same park, but because your values match. So he says that may last for longer time, and this there are many takers for this today also. Okay, so that is on some another legacy of Aristotle. Okay, so now we'll conclude with this. This Greek civilization was not just restricted to those people alone. There are lots of scientists, lots of people. Still we study Euclidean geometry. You go to students' books, you see they will, whatever they learn, axiom, Euclid theorem, whatever we learn, what is a straight line, what is a point, line theorem, everything is Euclidean geometry. Okay, you see 300 BC, very famous book called Elements. A guy called Pliny the elder and Pliny the junior, the botany, zoology fathers of that. Hippocrates, the first person who told that you get diseases not because of evil spirits which are written in your holy books, not a godly or divinely act, but there are insects and stuff which invades your body, and that is the reason why you get diseases. So we call him as father of modern medicine. Still the doctors take the so-called Hippocrates oath. Many people think that it is Hippocratic oath. Okay, both are two different things. Okay, Hippocrates and Hippocratic oath are two different things. Okay, so he was the person who made a distinction between things. And then few centuries later, a guy called Galen, another profound guy in medicine. So he took monkeys and all, dissected them. He told, okay, human and monkeys, human and other animals, probably we have similar kind of organs. So you can kill from the monkeys when they die. He did their anatomy, studied, and from that he tried to develop some theories. That's how the starting of anatomy comes. Galen. You see, almost all the branches whichever we talk about came from them. And all these things stand today. Archimedes theorem is still student study. It is still sacrosanct. Still we study. Okay, and Archimedes was maybe another polymath. He has developed defense equipment. He has developed instruments. He developed scientific theorems. So many things. The another guy, Eratosthenes, Greek time, 200, 300 BC. He found out what is the diameter of Earth at that time. Okay, so Maverick Experiment, Maverick, you have to give it to them how they think like that. So this guy observed, he was staying in a place called Cyrene. So he observed that during some part of the year, the sun is slowly coming above the head. Okay, so you know what happens when sun comes above the head? Like above the head means not literally above the head, like sort of closer to the head. The shadow will not be there. When sun is sort of above your head, shadow will not be there. Okay, so this is a question which normally people will be asked in IIM. You are in a desert and you see a tree and you want to measure the height of the tree. You don't have anything. How will you measure? The typical question used to be in IIT, IIM questions and all. So the shadow will change. Okay, so the shadow, he observed that in a well in his place, there's no shadow. You can see in the well sun exactly full round. Other time the shadow of the well on this side, shadow of the well on this. So these few days, 1, 2, 3 days, and then he identified every year Banda was waiting for that day, and he observed that specific one day he identified when there is perfect round. Okay, so when he marked that and he realized that that is 1 year after a few years, the next year before that day, he traveled 800 kilometers to Alexandria. He traveled 800 kilometers to Alexandria and he climbed on the top of a tree, a pole kind of tree. And from there, that time he saw there is a shadow. Because earth is curved, there is a shadow. And from there, he measured what is this angle. After that, it is plain mathematics. Once you know this angle, like we studied in the previous class, after that, it is straightforward, simple, back of the envelope mathematics. If you know this angle, which is angle measurement is a very old technique. Oops, I used the wrong pen, I think. Angle measurement is a very old technique. 1 second, okay. Format pen, let me take a small pen. Okay, and undo. Okay, so this undo. Okay, yeah. Okay, so if you know this angle, then like we studied in the last class, if you expand this, then you as well know this angle is equivalent to this angle, and this line are parallel because these are sunlight, all are sunlight, so parallel. Then you know this angle is the same. So if you know this angle, he got it as 7 degrees. So, and this 7 degree corresponds to 800 kilometer. Then he calculated 360 degree corresponds to around 40,000 plus kilometer. Well, he was not using kilometer precise. He was using some other unit called stadia or something. So we have some confusion. But the long and short of the story is that he got a very close value. The unit we are not very sure about it, but the idea is brilliant. Idea is brilliant, and years of effort through sheer observation. Does it ring a bell?
How did Aryabhatta calculate it? He also did, right?
Nobody knows. Aryabhatta is much later than Eratosthenes. It is around 4th, 5th century. No one knows how Aryabhatta calculated. Actually, Aryabhatta's value is very precise, some 30-40 kilometer different, but no one knows how the Bandha calculated it. Many theories, but he has not documented. See, these people that time, they were living in penury, you know. Nobody would have appreciated their work. In an extent, that's Ramanuja. He didn't have paper to write. So he's all this thing in small paper he has written. Now the people are sitting in all the foreign universities and Indian universities to decipher what he has written. So in order to save paper, 5 steps he writes as 1 step. Now we are not able to understand it. So these people, the whole society would have ridiculed them. You know, so but you know, in our place it was even they would have ridiculed further. Even there they would have ridiculed them, but at least they had some habit of documentation. So we have still more data. Our people's data we don't have. They haven't written anything. Whatever they have written is to save paper, pen. See, whole family would have asked, सुबह उड़ा, चला गया, कहीं तो ऊपर देखा, बैठा, कुछ काम धंधा नहीं है, देखो उसका भाई का देखो, कुछ करके घर पे कुछ लेके आते. They would have told that. So this guy, for him to explain to this family or people also what I am doing, I am trying to find out diameter of a patak बोल के देता था शायद. तेरी माँ की diameter, सिर्फ जाके कुछ काम कर. You know, it would have happened. So it's very difficult. It would have been very difficult for them to survive. Yeah. So this was this gentleman called Eratosthenes, and another Greek guy. Okay, this is the Astrolabe. Okay, this is that Parvati Nayar's that exhibition she was talking about. This one only. So this was a very old stuff. People used to use Astrolabe for so many things. They tell there are 1,000 things which you can do with Astrolabe. You can find the position of sun, moon, earth, and all. You can take the days. You can find the time. So many things. And Astrolabe people used to have as a pocket stuff at that time. It's a very old technique, but Greeks used it extensively during travel and everything for angle measurement and all those things. And this was Archimedes stuff. Archimedes stuff. He found out this thing. Okay, so Archimedes, like you know that famous story, right? The king asked him, like somebody, the goldsmith made some crown. We don't know whether it could be a myth actually. He made out of gold. Then the king doubted whether he had put some other kind of element also into that, some kind of a brass, copper into that. But how do you calculate it? How do you know it? It is very difficult to know. So when it seems the story was when he was taking bath, when he sat on the bathtub, the water spilled. So he got the idea that how much mass I am displacing, that much water is coming out. Okay, so till then the people's belief was that certain materials will float, certain material will sink. It is based on density. So he told no, there's nothing to do with density. He told it's all to do with how much water you displace. Ship is made of actually iron. Iron, if you just drop, it will fall down. But then what will happen? The shape of the iron matters. See, that's brilliant. Okay, you might be very robust material, very philosophical. You might be very robust material. Okay, but still, or you might be a light material or robust material. Even robust material, slightly by adjusting the shape of how much this thing, you can still float on. Okay, you have some control despite the material in which you are made of. You still have some control, some buoyancy. So he told, like, if something is on, what will decide where something will fall is how much water you displace. So this ship will displace this much water, this much water. So what will happen when this happens? There will be the weight of the ship, which is a force to fall down. Now you fall into water or anything falls, the weight of that will be trying to go down. But then how much water it is displaced, that will act as a counterweight to up. Then it is a contest between these two, who will win. So if you put a pepper or something, or if you put maybe a wood or something, what will happen is the weight of the wood is less compared to the water it displaces. So the above one will win. So it will stay. So if you keenly observe, the wood won't be like entirely floating. If you put a small wood, any piece, if you just keenly observe, you will realize that it is not like it is fully floating. It won't be like this. Look at it. It will normally be like this, slightly below water. So this below water, that much water is sufficient to hold it. But then when you put an iron or something, what will it to store? No, this much water, it will again fall. And when iron fell this much, how much water it displaces, mass of that, weight of that is not sufficient to hold this iron, because this iron's weight is more. So iron will sink, or you will sink. So that is what happens, right? So what will happen? So you change the shape of this ship. So this, the outer ship material alone, if you drop it just as a round ball, it will drop. But you change the shape so that you displace more water. Which means how much ever water is there in this, it is displaced, that much weight you can afford. That will decide how much freight you can carry, how many people can be there inside the ship. That is why ship falls when you have water inside, because the weight of the ship goes up. Okay, so you would have observed some people, if you fall, if you have depth in water, you know, after 2-3 days, they will come up. You know why? With this theory, you know why? Can you think?
The body swells.
Body swells, body floats. So it will displace more water. Body will swell, it will displace more water. Then you are not eating, so your mass will also reduce. So two things will come. So this will reduce, this will go up. So and that equilibrium, it will slowly come up. It will slowly come up. Understand? And this is a theory. This is called theory of buoyancy. This guy Archimedes developed at that time. You see, solved with buoyancy. Okay, so this was actually the story of Archimedes is that it seems he was a very famous defense equipment. With this, we'll stop. Okay, I want to finish with the Greek civilization, so this is the last slide. So this guy, it seems he was a very famous guy to design machines. Very famous guy to design machines. So it seems he was a guy who was making a lot of defense equipment. If you just browse, you can see videos of defense equipments he had brought. Archimedes had, it seems he had some technique to burn the ships which are coming to attack his country. Seems with a series of optical lenses. Like, you know, like a lens, if you keep, kids used to do that experiment. If you have a lens and if you keep a paper, after some point, the paper will burn, right? So like that, a series of lenses, you focus that into ship, you will burn the ship. That it seems there are myths like that, but National Geographic and all, they did, and even many scientists try to replicate it so many times, they couldn't replicate it. So they think it could be a myth. So he had many things like that, many defense equipment. So it seems the opponent country which was attacking him, it seems, had told that catch Archimedes alive, don't kill him, bring him, we need him, very important person. So it seems these people, when they went to him, it seems he was doing a mathematical experiment. So it seems this soldiers told him, come. Okay, so he told, get lost, I am in between this. So it will know we are the opposite country, you are been invaded. There are some story that they were not knowing this Archimedes. Archimedes told, get lost, I am in amidst this. It seems they killed him. And killed him, and you know, after long time only they could recover where it is. And then it seems they made a tomb of him. So this is a famous painting of this French painter. It's called Archimedes' tomb. So a gentleman called Cicero, it seems, after some years, went and discovered where is his tomb inside this forest. And the myth is that it had an image like this. Okay, so now they have made a new Archimedes tomb with this image. It seems he was trying to find out this. What will be the ratio if you have a circle, if you have a sphere inside a cylinder? What would be the ratio of their volumes, or how much space will be left? And it seems he had found out that it is 3:2. So how much volume this sphere, this cylinder can occupy, how much volume sphere can occupy. So finding volume of sphere is very difficult. Finding volume of cylinder is easy, uniform shape. Volume of pyramid is easy. Finding volume of sphere is extremely difficult. So, but Greek had a method. Very complicated method, very commonsensical method. Okay, so that is about Archimedes. So we will stop today at that point. So we have come up to around 2nd century, 3rd century. Oh, sorry, I will show one more thing. With that, I will stop. With that, I think we will conclude. Okay, so this is the Greek civilization. So they sort of ended. So this was one stuff which they had found out while digging, called Antikythera mechanism, I think maybe a century back. And people really struggled how to figure out what is this. And when they ripped it apart, there were so many gears and these things made of this. So it was an analog computer which they developed at that point. So now we have made so many replica. It seems by looking at this, you can tell when will be the next eclipse. What is the position of different stars? A much advanced version of Astrolabe. It seems it had moving parts. Antikythera mechanism. CBC 200 kind of stuff. Greek civilization. And okay, this I will leave it today. I will come to that. So this is like when you search for Google about this Greek scientists and all those things. Actually, this painting, Renaissance painting of Raphael, is what will come out. It's a very famous painting called School of Athens. And so each of this person, actually the beauty of that painting is whatever we told, each person, by seeing the action, their face expression, everything we can identify. So that is the beauty of School of Athens, you know. So you can see each person, you know, you can see very close to Euclid is making the drawing here, you know, and then different people. Zeno, he was always thinking paradox, these things like this. Pythagoras making this theorem, mathematical stuff. He's a philosopher. You can see Socrates arguing as usual, kind of stuff. And there is one lady in that girl, Hypatia, who was heading a mathematical institute there. The history is that she was killed because being a lady in that position during the time when they had Jews had conflict with Catholics in the 2nd and 3rd century. That is the end of Greek civilization. And there is a very famous movie came based on that called Agora, which won a lot of Oscar awards, I think 3 years, 4 years back. Very famous movie called Agora. Okay, so about the life of Hypatia at that time. Okay, so now you see, can you say what is that Plato and Aristotle, you see, can you see their movement? This is supposed to be Plato and Aristotle. Can you see how he represented them? How Raphael represented what characteristic? If you really look at this thing, it's brilliant actually. If you, so many details. You just zoom this. Can you see what was his representation of these two, arguably the most important people in this lot? See, this all are straight. Euclid and all are straight. Drawing, geometry, and all those very straight. Hypatia is not that straight, you know, cloth, dress, white, many other things, much more things. Pythagoras is a bit more reasonably straight, but he had a set of people called Pythagoreans. So there are more things to that. So it means much more detailed. But these people, you see, does it ring any bell to you?
They are structuring the world using reason and logic.
Okay. You see where their fingers are?
I can't see.
You can zoom. Can you zoom? Arguing. Okay, but arguing cannot be a characteristic to depict Plato or Aristotle, right? See, with one finger movement, two finger movement, he tells this is Plato, this is Aristotle. You see where are their fingers pointed to? Are you able to see? If you are in mobile, you can zoom.
Towards heaven and earth.
Ah, see, Plato is pointing to an ideal world. Ideal world. And Aristotle is telling observe earth to find out. Okay. We for jokingly, Mallus used to tell, I used to tell when I take class to Mallu guys, I used to tell this is Mammootty and this is Suresh Gopi. Two actors who always have this action. Okay. You can go and observe this. Okay, I thought I will tell this also and we'll stop at that point. Yeah. Anything you want to add?
About gravity that you said, isn't it Einstein's idea of gravity as a curvature in space-time that is not accepted? It is proven, right?
See, it is proven, yes, of course. Theory of relativity is where we stand today, and we have evidences. And we have observed gravitational waves. Even a few years back is when we observed gravitational waves. Yes, it is. So it is, but then still, if you have more mass, you have more gravity. If you have more mass, you have more gravity.
Yeah.
That is an accepted thing. So where from it comes is also a question. If it is not a force also, what is it that? He also tells it is curvature on earth, but when the mass is more, curvature is more. Yeah. So it is not that very simple and straight. Black holes occur because of gravity, no? So you need some explanation. Okay. It is accepted. I agree with you. It is accepted. It is the accepted theory. But then for all practical purposes in Earth and all, we use Newton's equation to find out gravity. Because for Earth and things, whatever we do, it is sufficient. But when you look at GPS calculation or all those things, you want to send America wants to send a missile to Iraq, you have to do it. Otherwise, instead of the military barrack, it will fall on the school or the hospital. Not that they bother about it, but maybe. Yeah. Okay.
Yeah. In one of your sessions, you discuss about that inductive and deductive, no? Deductive reasoning.
Yeah.
So I was just wondering, like, how this deductive reasoning, like, उसमें पहले theory कैसे आती है without observation?
Yeah. So that is the imagination. So that is imagination. Observation, you can only observe what is happening today, right? How can you observe what is happening in Mars? How can you observe what would have happened a million years before? How can you observe what is exactly happening inside the matter? Now you can observe, but before you are not able to do that. So there are things which you can't observe. Okay, and second thing is for observing also, you need to focus your eyes on that point. There are so many things in the universe, which all you can observe. So what to observe, how you will decide? How you will decide what to observe? So you come up with what is called as a hypothesis, not just pure imagination, some logic and some imagination. Then you start observing it. And end of the observation, if you prove it, even find one element you find it wrong, you tell this theory is discarded. But it is not that till you find out anything is wrong, you accept that theory. You need proof. You need experimental evidence. Without that, it cannot be considered as a law or a theory. But we haven't seen black hole. So we haven't seen the earlier this thing. So there are so-called prominent theories.
But that is not just an imagination. No? Black hole is not. It is an observation. No?
It is an we haven't observed black hole. We can't observe black hole. Because light itself
not observe black hole as such. लेकिन ऐसा कुछ तो space में होता है that we have observed, ना?
Yeah, that is observed after the hypothesis. After the hypothesis. It is not that you observed one day, then you derived it is black hole. You first derived.
That's what like अभी का.
Yeah. So theory came first.
अभी का session का बाद.
See, the theory came first. Like what
so that's what I was wondering.
Yeah. Tell me. No. What Aristotle
that's
told.
What I was wondering.
Yeah, what Aristotle told is not gospel truth. That is his theory. I'm not telling that is the end of the world. It's not the gospel truth. He told like that. It is fine. That is his theory. There are more people to come. There are more actors to enter the drama. Drama is only begun.
If you have time, there is one more question I want to ask.
Yeah, I have time today. I don't have any other class today.
We don't see electrons, right? Electrons or any subatomic particles, right? Like we use light to see this. Maybe at as far as molecules we can see using light, like we normally see using a microscope or something. But beyond that, we are not actually seeing these subatomic particles using light, right?
Yeah.
How do we see electron? When we talk about this quantum mechanism and all, these subatomic particles are as small as the particle of light itself. We cannot use them to see this. So how do they see that something happening there, like entangled particles entangled or things like that? So without
there are So the what we call as light is only one part of the so-called electromagnetic spectrum. So actually, what is happening is any body which is hot, will emit rays. Even just you have a matchstick, if you just light, it will emit rays, but it will be very less, so that you may not be able to figure it out. But it will also emit some light. So that what it emits is something called electromagnetic property, photon or whatever we call. So when any body which is hot will emit. Sun is very hot, so it emits more light. So in that whatever it emits is a whole pack, what we call as electromagnetic spectrum. So in that electromagnetic spectrum, light is only one component. So in that electromagnetic spectrum, there are more players. One player outside light, which is smaller than light, smaller when we tell the size of the wave, smaller than light, is called gamma. Another one which is smaller than light is called X-ray, which all we use. So light itself is bigger compared to this small material, subatomic particle. So our normal light cannot go and detect it, because in that light ka wave ka jo length hai usse chota hai, so usko niche padega, you can't detect it. So that is why inside our body also, if you want to find out whether anything is there, we don't send light, we send X-ray, because X-ray is much shorter. So X-ray ka wave, uska jo size jo hai, that size and above particle ko it will detect, so it will stuck there. So in the X-ray we will see either X spot hai, so their X-ray has not passed. So when it come to in fact you hit on a very important point. In fact, that is our biggest constraint. The smaller the wave becomes, the smaller the size of this electromagnetic spectrum becomes, the larger the energy you need to produce it. Because why it is, chota ho gaya to number of particles needed is more, number of waves needed is more. What we call it as frequency, number of waves in 1 second. Abhi traffic mein bola idhar mein khada raha, how many cars went in 1 hour, that is the frequency of traffic. How many cars in 1 hour, or how many buses in 1 hour, that is what we call as frequency. Okay, or we tell FM radio 104.3 megahertz. So 104.3 into how much ever waves are, that many waves will be there from that station, whatever signal comes, that many waves, that is the frequency. How many number per second. So now if this wave, if that length is, if that wavelength, whatever we call it, if it is shorter, you will have, what will happen, it is like you have a toll booth. In the toll booth you are standing, here only truck hai, next toll booth mein only car hai, next mein only scooter hai. So same length, if you see the truck toll booth mein, you will have less number of trucks compared to the car line, and car will have less number of cars compared to the scooter. Is it not? Scooters will be more because uska length chota hai. For the same toll ka road ka length mein, scooter you will have more number of scooters. So that's why people, smart people will stand in a queue, they will see how many trucks are there on the other line, they will stand behind the truck. Public or truck dekhe, some people will not stand behind the trucks in toll, but truck ka na ek hi, engine to ek hi hai na. Car hai to 3 car will have to give tolls and has to move. If it is one truck, actually in the truck lane you will reach faster because the number of trucks will be less. So this also works that way. So if when your number of waves, wave ka length chota hai, to you need more, you will have more waves, whose frequency zyada hai, so you need more energy. So what will happen when you get into subatomic particle too small, you need so much of energy to produce that kind of waves. That is why this particle experiment, you need a village size, a town size power stations to feed it. And that is our biggest challenge. That is our biggest challenge, to study about what happened during the formation of universe. So during the formation of universe, the energy levels, we can never reach those energy levels now. But if we have to conduct experiments, we need those energy levels. So that is the biggest constraint. So as science progress, when we started developing more and more power, more and more energy, more and more sophisticated testing equipment, we are finding out chota particles. So these small subatomic particles, it was impossible to find out last century or last century, because of the same reason which you told. Because normal light is bigger than this. So that light cannot find out, because this is so chota. Light will cross it and go. So that is the problem in doing that. So these chota rays are used to find out these things. So we develop new kind of waves, small wavelength waves, to find out this, to match that. Do you get that, Arun? Okay. And as you asked, just to spin your head, that is actually the reason behind something called uncertainty principle, which shook the world politically, philosophically, and all. Because when you have the smallest particle to find out, if you want waves which are of very high energy, you send this wave to find out whether that particle is there or not. This will go and hit that particle, its speed will change. Right? You are trying to identify a particle and you are sending a wave. He will go and see how we are seeing something, the light from that particle when that object hits our eye. Here we are sending light. This will go and hit that, and this is high energy. Right? So the smaller the particle is, to find it out, we need the kind of waves of higher energy. So the more the energy, it will, when it goes and touches this particle, it will move that particle. Which means you can never find out the exact position and speed of a particle. That is the theory called uncertainty theory. And that is why people in Soviet Union that time refused to believe it, because they believed in certainties. They believed in scientific determinism. They believed by telling that the whole world can be explained and defined using science, using rational theory. So they told, how can we agree by telling something is not predictable? That's why uncertainty theory created so many ripples in political circles and philosophical circles and all. Here you are admitting that we can never find out what is the exact position, because the smaller the particle is, its mass is very small, and then you hit with a higher energy, it will move. So you can never find out the exact position. You can only assume, uncertain, which is the ramifications of that is very huge. You get that? Okay, I think enough for the day.
Okay.
And I am fine.
Okay.
Projekta seems to be, by this time, 2 classes before means Projekta would have run her. Slowly. Today she is in full mood. Yeah.
नहीं, लेकिन अभी ये जो सब what you were talking about uncertainty और ये सब चीजें, तो ये सब चीजों का लाइट है या फिर स्पेस है, फिर बहुत सारा और भी कुछ ऑब्स्टिकल्स रहेगा, ये सब चीजों का अर्थ का मूवमेंट पे कुछ फर्क नहीं?
म्यूट हो गया. अर्थ का मूवमेंट में क्या फर्क, मतलब
जो हम लोग पहले बात कर रहे थे, then earth is also, if we consider earth as a particle, ठीक है, तो उसके ऊपर ये सब चीजों का कुछ फर्क नहीं पड़ता क्या?
फर्क पड़ेगा. Yeah, you are right. Yeah, you are right, but earth is so huge na, mass is very heavy, so a normal light ka energy is nothing compared to the
not only light but other stars है उसका भी. तो how do you, like how do we calculate it? जो हम लोग last से बात कर रहे थे 4 मिनट में एक, इतना perfect calculation कैसे मिलता है फिर उसमें?
Yeah, we will come to that, but the thing is, if a star comes and hits earth, earth will move. Or if a meteor comes and hits earth, earth will move. But if a ray from the earth, some star will come and hit earth will not move. Because the comparative energy of the so-called rays, electromagnetic rays, is nothing, minuscule compared to size of earth. So if you have to move something, you have to overcome something called inertia. So we will learn that. So you have to overcome something called inertia to move something. So earth has so much of mass. To move earth, you need that much force of inertia to move it, which the light doesn't possess. Any kind of light doesn't possess. Does that make sense?
लेकिन इसके पहले तो हुआ है ना काफी बार, like not just because of light but other things.
Yeah, and that also can happen. If a meteor comes and hit earth, it can happen. That has happened. No, that is how the continents and all got formed. That abhi bhi ho sakte hai. The point is, if matter comes and hits you, depending on that matter's mass, it can move. But the particles do not have that much energy. Yeah. Okay. See you next class, next week. Bye. Bye, Bharata sir. Okay. Bye.